Yeah. Okay, so are there any questions regarding like the MyOpenMath problems?
Can you go through 5.6?
Sure. Which any problem in particular?
Actually, the notes.
Okay, the notes.
Yeah.
Oh, Professor. Hello?
Yes.
Oh, I actually have problems getting onto the streaming. Like, for example, like last class, even though I was here, I just wanted to like look over the notes, but I can't get into the actual using the link. I can't get into the video.
What are you? What do you see on your screen right now?
It says this may not be for you. It looks like you don't have permission to watch this video.
Are you logged into, when you click the link, did you log into your MCC account? You need to use your MCC login.
Yeah, I'm on it.
Okay, hold on. This is guest. Okay. No, that's not it. Yeah, I don't think you're logged into your MCC account. That's why it says guest under your name.
Okay, I'm logging out and then I'm gonna log back in. Yeah, it's still saying the same thing. Even when I log in.
It doesn't have your MCC information under this account.
What do you mean exactly? Like,
Okay, so what link are you clicking on to join
the one directly from Canvas every time.
Okay, so do this instead. Go to the main Middlesex County College website. Okay, so middlesexcc.edu. At the top of the page, you should see My MCC in yellow. So click on that.
Okay, wait, My MCC.
Then click on Office 365.
Uh-huh.
And then choose Teams.
Not Teams.
on on the Office 365 page at the top, does it show you that you're logged into your Middlesex County College account?
Yeah, I'm always logged in, so that's why I don't really like check it. But yeah, I am logged in. Microsoft Teams. Am I supposed to enter a code? It says to join a team with a code.
So on the Office 365 page, at the far top right corner, what does it show as your account?
Let me check. My MCC. It's not coming up.
So on the Office 365 page, it should have your initials, and if you click on it, it should show your my Middlesex County College email address.
Yeah. It does. In Office 365. And the side it says, Rashana, you're welcome. Yeah, it has my profile. Yeah, my profile and my Middlesex ID. And then when I press on Teams, it just has the home, basically. And it asks me to like join a team with a code.
Okay, so for some reason it doesn't show that you're online. Oh, okay, here you go. Can you see the chat that I started?
Yes.
Okay, you should be able to enter now. Hold on one second. I'll give you the link again.
Oh, look at that. I do see it.
Right, so click on the link in the chat.
Oh, okay. Oh, so it's like
Okay, so you have to close your other window because there's feedback now.
yeah, it does close it. Okay.
Okay. Yeah, you should be okay now.
Okay, thank you.
Yeah, it might be that you have two different Office accounts, and so it's confused about which one you're logged into.
Oh, okay. Yeah, I do have to. Okay. Thank you.
Yeah, so next time, I guess go through the Office 365.
Mm-hmm.
So enter Teams through there, and then in your chat window, you should be able to see the meeting for this class, right? So it will be the ALS3, CLS3 link. You should be able to see this link, and then next time you just need to join the same meeting again.
Okay. So would I be able to access the older lectures?
I'm sorry?
Would I be able to access the older lectures?
Yeah, all the some of the older lectures, because like I always have to set it to record manually every time. So some of the other lectures I did not record the entire lecture. But there should be videos covering all the topics, right? So
Okay.
if you go into the why isn't, oh, no wonder I'm not sharing my screen. Okay, that's why you can't see the video. Okay. So if you go into the Canvas page, so all the class meetings that were recorded are there, right? So like last class on Monday that covers section 6.6. So that video stream is there. But like say April 1st, um, I forgot to record the entire thing, so it's missing part of the beginning of the lecture. But I mean, for section 6.3 and 6.5, there are separate videos for those sections, right? So you can look at those videos instead to cover those topics. So there should be videos that cover each of the sections that we've gone over in chapters 5 and 6, listed on the Canvas page. um, but this lecture is recording everything, so it will have everything for today. Okay, are there any other questions?
5.6.
Yeah, so section 5.6. So what did you want to go over in particular?
Recognizing asymptotes and like graph, basically. Graphs, especially.
So in in terms of vertical and horizontal asymptotes, right? So basically what you want to look for is where if the graph is bending towards some imaginary vertical line. So here you can see it's bending towards the y-axis and going upwards here, and it's bending towards the y-axis here, but going downwards, right? So so if you see something like this, that means that there should be a vertical asymptote at that location. And so vertical asymptotes are described with an x value, right? Because the y values are changing, but the x value is always equal to 0 here. And similar for horizontal asymptotes, it's bending towards the x-axis here. So there's horizontal asymptote at y equals 0, and it's described with the y value, right? Because the x values are changing, but the y value is always 0 at this horizontal line. So, I mean, in terms of looking at the graph for the asymptotes, just pay attention to where the graph is bending towards, either vertically or horizontally. So usually for vertical asymptotes, it's going to be, so you'll see that the graph will have a break somewhere in the middle, and the graph bends like this. You'll see the vertical asymptote. But for the horizontal asymptotes, usually you want to look at the left end So where it's trending towards on the left end, or where it's trending towards on the right end. So, like for example, so say I give you a graph and I don't draw in the asymptotes for you. Right, so some graph like this. Okay, yeah, so something like this. Right, so if I give you a graph like this and you need to figure out where the asymptotes are, right? So in terms of like say the horizontal asymptote, you can see that it's bending the graph. When you go to the left, it's bending like this, and it's getting flatter, right? So same here. When you go to the right, it's getting flatter. So there should be a horizontal asymptote around where this is occurring. I didn't draw very exact, but it should look something like this, right? So and then now, if you want to say where the horizontal asymptote is, right? So where does it cross the y-axis?
2.
It's 2, but you're going down, right? So what does that mean?
-2.
It's -2,
Mhm.
right? So and it's hitting the y-axis, right? So you say it's at y equals -2.
Yeah.
And you do the same thing for the vertical asymptote, right? So here you can see that it's bending this way, and on this side it's bending this way, right? So you can see how this portion of the graph is separated from this portion of the graph.
Mhm.
So in between them there should be a vertical asymptote.
Yes.
So you just sort of draw it in about where it is, and then in this case it hits
3.
around here, right? And then that's an x value, right? So it's at x equals 3.
Okay. Right. And then
Hey, good evening, Professor. Just joined in. We're going over the review, right?
No, not yet.
Okay.
I'm just taking general questions.
Okay, gotcha. All right, I have some for you. I'm gonna just find them real quick and get back. Hold on.
Okay, so in horizontal asymptotes, it's page number 3 from the notes. The top example is, can you explain that if the arrow is above the asymptote and if the arrow is below the asymptote?
It doesn't matter whether it's above or below. The answer is always the same.
Okay. But what does that mean if it's above or it's below the asymptote? Does that mean something, or it's?
Yeah, I mean, for the purpose of our course, it doesn't really change anything.
Okay.
You always write the answer the same way.
Okay.
But if you really want to get technical, when it's above or below, and what does that mean in terms of the graph, right? So
Mm.
things that are higher have a bigger y value, right? And
Okay.
things that are lower have a smaller y value,
Okay.
right? So and what's happening at a horizontal asymptote is that, and so like say you look at this portion here, the y values are getting a little bit bigger and bigger and bigger, right? Because you're going slightly upwards. It never quite reaches the asymptote. So like say the asymptote is at 2, right? So
Mm.
that means that the y values of the function get close to 2, but it doesn't actually quite reach it, no matter how you calculate the function.
Right.
So it might be like 1.9999999 or something. And if it's below, that means it's slightly smaller than 2. And
Okay.
if the graph is above the dotted line, that means it's slightly bigger than 2. Right? So it will be 2.00001 or something.
Okay.
Right? So I mean, if you take a look at the function on the first page, right? So x plus 1 over x minus 2. Okay, so the function here, on the left side, it's below the horizontal asymptote. On the right side, it's above the horizontal asymptote. Right. So what that means is that if you calculate for the function, it's going to be close to 1, but it's not going to be exactly 1. Right. So like say you're looking at the right end, that means the x values are large. Right. So let's calculate that. Say x is 10,000. Okay, so if you plug it into the function, what do you get? So it's 10,001
1.
divided by 9,998,
90.
because you subtract 2. And then you see that the result is slightly bigger than 1. So
Yeah.
that means the graph is above the asymptote. And if you go to the left, that means the numbers are big but negative. Right? So say negative 10,000. Then now the numerator will be negative 9,999.
Mm.
And the denominator would be negative 10,002.
Mm.
So now you'll see that the numbers are close to 1, but it's slightly smaller. Right? So that means the graph should be below the asymptote. So I mean that's all that means. It's close to the number, but it's either
It's not
slightly
X.
bigger or slightly smaller.
Right. Okay. And then the hold, removable, discontinuous. No, actually, jump. Yeah. Can you explain a little bit about both?
Uh,
Just from the notes.
so holes are just where a function is undefined.
Okay.
Right? So like if I give you a function, say a function, say I give you 2 different functions. Right? So one function is the function x plus 1, and another function is x plus 1 times x minus 2 over x minus 2. Right? So uh, your immediate reaction might be to say that the 2 things are the same, right? Because the thing on the right, that you can cancel out the x minus 2,
Yes.
and then what you're left over is x plus 1.
Yes.
Right? Your initial thought might be that they're the same, but they're not actually the same.
Okay.
So they're the same except for a single point, and that's where the hole occurs. So
Okay.
the reason that they're different is that the thing on the left is The
Without
domain
all-
is all real numbers because it's a polynomial. But the function on the right has a restriction on the domain where x is not allowed to be 2 because you can't divide by 0.
Hmm.
And so the function on the right is undefined when x is 2, again, because you're not allowed to divide by 0. And this point where it's undefined is where the hole occurs.
Okay.
And so that's so that's why, I mean, so you can see that the x minus 2 appears in the denominator, right? So the function is undefined there, but the x minus 2 also appears in the numerator, right? So this factor appears in both the bottom and the top. And so that's why if you look at the discussion on where holes occur, right? So you to determine where the holes occur, you look for common factors that appear on the top and the bottom. So so something like this where x minus 2 appears on the top and the bottom, that tells you that you have a hole at x equals 2.
Right.
Whereas, I mean, if you look at this function here, it also has x minus 2 in the denominator, but instead of having a hole, you have a vertical asymptote instead. And the reason is because in this function, the x minus 2 appears on the bottom, but it does not appear on the top. So it's undefined there, but the way it's undefined is different. You have a vertical asymptote instead of a hole.
Right. Okay. And the jump?
Uh, so you don't have to worry so much about the jump.
Okay.
Because it doesn't show up in the section.
Okay.
They have to do they deal with piecewise functions, but we didn't do piecewise functions in this chapter.
Right. Okay. But I guess the last question, no, the question number 2 is from jump, right? Example 2.
Which example?
If we go to the next page, page number 4.
Yeah, yeah. I mean, yeah. There's a jump here, but again, I mean, if you look at the my open math problems, they don't have any. They have jumps in it.
Okay, right. Sorry, I didn't do the 5.6. Okay. And question. Okay. And the last question for no, that's okay. Thank you.
Okay. Are there any other questions?
No, let me see for. Okay, so from 6.6, I mean, are we allowed to have a graph in front of us? The first page graph where you can see the roots.
6.6.
No,
there are no graphs in 6.6.
not a graph. It's a table. It's a table in the 6.6.
Oh,
The first
the
yeah.
table.
Yeah. Or
Yeah,
it'll be given in the test, like.
yeah, you can have it in front of you.
Okay.
Yeah, if you need the table, you can use the table.
Right. Hmm. I think Snehashish was asking a question. He was waiting for me to finish.
Yeah, I think he's not. He's probably not at his computer.
Oh, it's. Question 3 in the test 2 review.
Oops.
Question 3 is basically a division. Long. It says divide and simplify. So okay, it's a division.
Yes, it's division, but you don't have to use a particular method to do the division. Right, so like for example, B and C, you can use synthetic division.
Yes.
Right, because it's
X
x
plus
plus
2.
or minus some number
Yes.
in the denominator. Whereas
A,
you won't be able to do synthetic division for A at all.
but we can divide 3 by everything. Like
Yeah,
3.
yeah. So you can just distribute the thing on the bottom into each thing on the top.
Okay. Right. And then zeros are basically the x-intercepts, right?
Yeah, so zeros, x-intercepts, roots, those all mean the same thing. Right, so in the problem 2, you would want to factor everything, and
Right.
then you have to remember that the factor and the zero has opposite signs, right? So when the factor is x plus 1, the zero is going to be x equals negative 1.
Yes.
And then the power of the factor is the multiplicity.
Yes. So multiplicity is basically the sum of all the degrees, right?
No, the degree is the sum of all the multiplicities.
Okay. Right. So just the highest degree.
Wait, the degree is the sum of all multiplicities?
Yeah.
Right.
You're breaking up.
So in question number 2, the degree would be 2 and leading coefficient would be -1? No.
Well, which one? There's two functions, a and b.
A.
Okay, so for 2a, so So for 2a, it's it's better to do part 2 first. But in any case, yeah, because then the degree is just adding the multiplicities together, right?
Yes.
So what is the function? Let me just copy that. So a. So f of x is 3x times x plus 1 squared times x minus 3. Right, so let's look at the zeros and multiplicities first. So what does that mean? You set it equal to 0, right?
Yes.
And then you do each factor separately.
Yes.
You have
3x
3x
equals 0.
0.
X plus 1 whole squared equals 0.
Squared equals 0, and then
X minus 3
x
equals 0.
minus 3 equals 0. Okay, so
Right.
then what does this get? X equals 0, x equals minus 1, and
Plus
x equals 3. Right, so those are the zeros. You have three different zeros.
Okay.
And what are their multiplicities?
2.
So you have to look at the power of the factor it came from, right?
Wait.
So for x equals 0, you look at the x here.
Mhm.
What is the power for x? It's
1.
1, right? Because when there's no power, it's 1.
Yes.
So this would be multiplicity 1. And what about this one? This came from this factor. And then this factor had power 2.
2.
So this multiplicity would be 2. And then x equals 3 came from this one.
1.
And then this has power 1. So this multiplicity would be 1. Okay, so those are the zeros and multiplicities.
Okay.
Professor, I'm sorry. Why is the multiplicity for x minus 3 equals 0, 1?
Because the power is
Okay.
1.
I'm sorry. Yeah, I didn't see that. Okay.
So the leading coefficient would be 3.
Yeah, so the leading coefficient is 3. And what is the degree?
It's 2. No, sorry.
You have to
2.
add the multiplicities together. So it's 1
4.
plus 2 plus 1, which is 4.
Okay.
But the reason that you add the multiplicities together is, what is the degree, right? So the degree is the power of the highest is the highest power for x, right?
Yes.
But to be able to get it for this one, you would have to multiply everything out to make the thing look like a polynomial.
You mean distribute it with 3x?
Yeah, distribute everything, right? So then FOIL everything also.
But x minus 3 wouldn't be foiled, right?
Yes, you have to FOIL everything.
Oh, okay. Even though if it's to the 1, its power is only 1.
Yeah.
Okay.
But it's very tedious to FOIL this whole thing out.
Right.
Right. So you need to do it a different way. So how do you do it? Right. So where is the highest degree term, the highest power term coming from?
X plus 1.
No. It's not coming from the x plus 1.
Wait, what was your question again? I'm sorry.
So let's look at another example, right? So if I give you x minus 2 times x plus 3, and I ask you to FOIL this out, right?
Right.
What is the highest power of x going to be after you
Squared.
FOIL it out?
Squared.
X squared, right?
You're right.
Because where is it coming from? It's x times x here.
Yep.
It's x times this x.
Mm-hmm.
Okay, so and that's where the x squared is coming from. But this one only has two factors, right? This factor and this factor.
You mean the
Whereas
2 and 3?
no, the factor is the whole thing in parentheses.
Okay.
Okay, so this factor and then this factor.
Right. That
Whereas
has three.
this function has 4 separate factors,
4.
right? Because there's a 3x, and then this x plus 1 is being squared. But what does it mean to square something?
Foiling.
Multiply it by itself.
Right.
And then there's this x minus 3, right? So this one has 4 different factors that you would have to FOIL it out. But you don't actually have to FOIL it out. You just have to think of where the x is coming from, right? So if I were to FOIL it out, where's the highest power x going to come from? It's this x times this x times this x times this x, which will give me x to the 4th, right? So that's why the degree is 4. And it's the same as if you were to just add up the multiplicities, right? Because there's one copy of this x, there's 2 copies of this x, and there's 1 copy of this x, and then in total there's 4. Okay, are there any other questions?
And behavior.
Yeah, and behavior. I mean, hold on. I'm gonna just if you can. I mean, you don't have to go over every single one. I was thinking if you can go over number 4. I mean, I'm sorry. You can go over the end behavior first, because she asked before me.
Okay, so what is the end behavior? So you have to look at the degree and the leading coefficient, right? So in terms of the degree, you have to look at whether the number is even or odd, right? So 4 is even. And for the leading coefficient, you look at whether it's positive or negative. Right, so 3 is positive. Right, okay, so degree is even, the leading coefficient is positive, and okay, so now we just have to follow what the end behavior should be, right? So this was from section 5.2, right? So what does it say in section 5.2 in terms of the end behavior? Right, so again, for the degree, you're looking at whether it's even or odd, and for the leading coefficient, you look at whether it's positive or negative. Right, so what did we have? The degree was even, and the leading coefficient was positive. So
3 and 4. So positive 3 and degrees even 4.
So leading coefficient is positive, degree is even. So the end behavior should be this.
Oh wow. Okay. It's like almost like the table you had for the powers.
Yeah.
Okay, that's very very straightforward. Cool. Wait. Would so we'd write it out if on the exam.
Yeah,
we would
just write
write
that.
end behavior equals, and we just put left, just write it out as it is, right?
Yeah.
Ooh, I'm nervous and excited for this exam at the same time.
Okay. So uh, so question 4.
Question
Uh,
4.
so what did you wanted to go over for question 4?
So for instance, can you just go over A and B?
I said you can skip A, right? So you don't have to
Okay,
worry about A.
all right, then just B then.
Okay, so what is it asking for B? What are the rational zeros? Ignore the word rational. It doesn't really mean anything in this bottom problem, right? So what are the zeros of the function according to the graph? Right, so zeros mean the same thing as x-intercepts, right? So if we were to find the x-intercepts for the graph, where should we look?
At x
On the on the x-intercept. I mean,
0 when y is 0.
yeah, okay, I'm blanked.
Where y is 0.
Right? Yeah. So you would, but what does it mean when y is 0?
It crosses the it crosses the x.
Right. Right. So the x-intercepts are where the graph crosses the x-axis.
Yes.
Yeah.
Right. So where does the graph cross the x-axis?
Oh my God.
3
What do you
points.
call it? I don't know why I just did something so silly. Wait, what were you saying? Is it 0 and
Well, you're looking at the graph, right?
right?
And where's the x-axis?
I think it's 3 and -5.
Where are you getting -5 from?
Okay, because I'm looking at the bottom of the graph, the bottom of the parabola, I guess.
So where this line here is the x-axis,
Right.
right? So
So then it's just
where
0 and 2, 0 and 2, 0 and 4. I mean 2 and 0, 4 and 0.
oh ignore the y coordinate. Just give me the x values, right? So
2
what
and
are the
4.
x values where it crosses the?
Can you zoom? Like it's on
Oh, so
one
how many times does it cross the x-axis?
3 times.
Twice. So it's on 2 and it's on 4. Right?
It crosses one more time.
3 times at the negative side.
3
Yeah,
times.
it crosses
Oh,
3
yeah,
times,
yeah.
right?
It's -2. -2. Okay.
Right,
Negative
so
Yeah, thank you, bro.
-2,
Thank you for that.
-2, 2, and 4, right?
-2, 2, and 4.
Okay, so those are the zeros.
Oh, that's it.
Do I have? Right, so you're looking here, here, and here, right?
Yeah.
So that x equals -2, x equals 2, and x equals 4. This program is not good. Let me use a different program. No.
What? Wait, you teach discrete mathematics, professor?
I teach it sometimes.
What?
Oh, it's this program again. Okay, so where okay, so where are we looking at? Okay, so x-intercepts, right? So crosses here, here, and here, right? So where are they? X equals -2, x equals 2, and x equals 4. Okay, so those are the rational zeros.
Okay, wow.
You don't have to worry about the word rational. Those are the zeros. That's it, right? So that's B.
Yeah, and then completing factor.
Right, so completely factor f of x.
Right.
Right. So if you look at okay, this one is actually not too bad to factor, but in any case, when you have a cubic, it might not be so easy to factor, right? So an alternate way of factoring it besides looking at the polynomial is to use the zeros. Right? So it's the same thing as what we did before, except we're working backwards this time. Right? So what did we do before? So in this problem, right? In problem 2, you are given the polynomial already in factored form, at least this one, right? This is
Right.
already factored. And where did the zeros come from? You separate the factors and you get them one by one like this,
Mhm.
right? So now what we want to do is we want to work backwards, right? So we have the 3 zeros. We need to figure out what each of the factors are now.
Uh,
So how do we write down the factors? Right? So it's just gonna be x plus some number or x minus some number. Right? So how do we figure out? It's always the opposite sign of the 0, right?
but we have three zeros, right?
Yeah, we have 3 zeros. This
Yeah.
one also has 3 zeros, right?
Yeah.
Right. So when the 0 is x equals when the 0 is -1, then you write the factor as x plus 1. When the 0 is 3, then you write the factor as x minus 3. Right? So it's always the opposite sign.
Okay, so then, what do you
So
call
you
it?
just do it one by one for each of the zeros, right? So when the 0 is x equals -2,
It'll be
the
x,
factor will be in parentheses x.
3x plus 2.
There's no 3, right?
Oh, okay, you're just factoring into the parentheses.
So the factor would be x plus 2. And then you do the same thing for the other ones. Right? So when the 0 is positive 2, you write x.
All right, really? It's x minus 2 and then x minus 4. Wait, really?
Right.
All
So
right.
yeah, so this would be x minus 2 because it's just the opposite. It's the same number but the opposite sign, right? And this
Right,
one would
right.
be x minus 4.
Wow. I feel
Yeah.
like a dunce. Okay, yeah. I guess this is the consequence of uh, missing out on a couple of classes. That's very straightforward. I thank you for explaining that. Um,
Well, so so I mean that's the answer for this one, but I mean, all the answers are there, right?
right.
Which one?
You said prior
Four,
to
three.
you beginning to explain the answer for 4C. You said that this factor here is actually particularly pretty easy. Um, oh, what would be the most complicated expression, or yeah, complicated rational zeros to backtrack into into its factored form? Ignore. Sorry about that.
Well, I mean, I was referring to a different method of factoring.
Oh, okay.
Right?
Okay. So then,
So the way we want to do it here, when you have a graph like this, is just to take the zeros and then write them one by one, like we did here. The other way of factoring it is to do it like this, right? So this one you would group them like this, but because there's a minus here, this has to change to a minus, right? And then you factor each of the two things separately. Right? So what do you get? So x squared comes out of the first one, right? So that's x squared times x minus 4. And then this has a common factor of 4, right? So you get 4 times x plus, not x minus 4, because this is minus, right?
yeah,
So
x minus 4.
And then now both of these have x minus 4, right? So you can write x minus 4 times x squared minus 4. And then this thing is a difference of squares, right? So then it becomes x minus 4 times x plus 2, x minus 2. But you can see, I mean, they're in a different order, but it doesn't matter the order. These three things are exactly the same as three things.
Okay.
Right.
Yeah,
So
yeah, it makes complete sense.
What I meant was that for this problem, you could have factored it this way, but this way would be more complicated than just reading off these three numbers and writing it out like this one by one.
Yeah, yeah.
That's what I was referring to.
Okay, just getting there 10 times faster instead of doing the opposite. Okay.
So one additional thing to be aware of is that this one, the coefficient of x cubed is 1 for the original problem, right? So that means that this doesn't have any coefficient here. But in general, you might have to figure out what the coefficient, what the coefficient here is.
Well, the coefficient would be
A.
1. So yeah,
Right.
and then the
In this
degrees
case,
of
A is 1. There's nothing to do, but in a slightly different problem, you might have to figure out what A is.
and Professor, you already went over 12, right? Or no?
Yeah.
Yeah, he went over. Okay. Yeah, okay. I can look back at that. It's no
I
problem.
didn't go over the specific problem, but we went over the basic ideas, which are like how to tell where the vertical asymptote is. Just look at where the graph is bending and so on.
Yeah. Okay.
What was your question in this, Professor? Question 4, what's the coefficient?
Yeah, what is the coefficient? And this one, it's 1 because you already know what the leading coefficient has to be.
A.
Because the leading coefficient for x cubed is 1. Right? But I mean, if you look at the example from section 5.2, right? So it's on the it's page 4 of the section 5.2 worksheet.
Yes.
At the bottom, you have essentially the same example. right? So you identify the zeros and their multiplicities.
Right.
So you have the 0 here.
-4,
Here.
-2, and 3.
Yeah, and then
It's 1, 1, and 2.
yeah, so the multiplicity would be 1, 1, and 2.
4.
And then total degree of 4. So the multiplicity here is 2. The reason is because
Yeah, it's
math
skewed.
bounces off the thing instead of going through the intercept.
Right.
And okay, so
The
what were the zeros? It was -4, -2,
and 3.
3, and then this was 1, 1, 2, right? So when you write it out, it's x plus 4 to the first
X,
power,
yeah,
and x plus 2 to the first power,
3.
x minus 3 to the second power,
Yes.
and then there would be a coefficient there, except in this problem, this problem is the same, but it's also slightly different, right?
Mm-hmm.
Because this problem, I give you the original polynomial in a
Yes.
different form. But this example, I don't give you the polynomial at all. I only give you the graph.
Yes.
So that makes it more difficult to figure out what A is.
Yeah.
So what you want to do to figure out A is to use, right, so the x-intercepts
Yes.
give you these three numbers. The other
Yes.
thing you want to use is now the y-intercept.
3 and 0 and 3.
Yeah, so the y-intercept is at 0, 3. Okay, so that means that x is 0 and y is 3. So we can now plug it in. So this is y, right? F of x is y.
Yes.
So when you plug it in, you get 3 is equal to a times, and when x is 0, this is 4.
Wait,
X is 0 here,
why
this is 2. And when x is 0 here,
Oh yeah.
like when it's 0, it doesn't do anything.
Right. Yeah.
And so when this is 0, it's just -3, but then there's also the square here.
No.
Okay, so then now
So you're not.
we can use this to figure out what A is, right? Because 3 is equal to A times, and you just calculate this out. What is this? This is 8.
8 and then 72.
Okay, so that's 72. And then so A is 3 over 72.
Oh my god. You make it look so easy. When you explain it, it's so simple and straightforward. I've never had math being taught like this.
The point is to practice these problems so that
Yeah, it becomes habitual. Quick question.
okay. So that's the idea behind. Whoops. Well, I don't know what happened. Okay.
Just erase that.
Yeah, so that's the idea behind this problem, right? So just list out the points where it crosses the x-axis one by one, and then you just rewrite each of them as an individual factor. And again, this problem, the coefficient was automatic because this was given to you, but if it's not given to you, you would calculate it this way.
Okay. Do you mind going over 8B, 8B and 8B, C, and F? I'm sure they're very simple.
Uh, so
Yeah, I chose B because it has a log of 5. Yeah, they're just all each one is a different variated type. So I figured just have you go over it.
So let's say this thing is equal to y, right?
Yeah.
So what are the different pieces?
All right, so you can't talk once 5:15 hits.
What are the different pieces of the log?
No, you're gonna.
Right. So we want to write it. We want to write it in exponential form. Right. So the number here is the base, and then the number here is the exponent. Right. So now we rewrite the thing. Right. So the base is 5. What is the exponent? The exponent is y. And what is it equal to? It's equal to this thing. Right, so this is the result. Right, so 5 to the y is equal to square root of 5. Okay, so now, so we want to convert the log into exponential form. Right, so now it's in exponential form. And what do we want to do when it's in exponential form? You match the base, right? So the left side is 5 to some power. So I want to write the right side as 5 to some power. The square root, what does it mean to take the square root of something? It means it's raised to the 1/2 power, right?
Yes.
So that means the power is 1/2. But now the left side is 5 to some power, is 5 to y, and then the right side is also 5 to some power, right? It's raised to the 1/2. So because the bases are the same, that means the exponents have to be the same. And so y has to be 1/2.
Right.
Wait. How is the base 1/2? You said if the
So,
base is the same, then the exponent has to be the same, right?
yeah.
So, wait, you didn't use the calculator, right?
No.
Okay. But my question is, the base isn't. How did you get 1/2 from 5?
So when you have the square root of something, what does it mean in terms of an exponent? It means that the exponent is 1/2. That's where the 1/2 is coming from.
Okay. So it'd be the same thing with any number,
Yeah, so
right?
like if you have
It,
square root of 7, that's 7 to the 1/2 power.
okay.
And
Cool.
square root of 8 would be 8 to the 1/2 power.
Well then, why isn't that being applied to 5?
Which 5?
Well, shouldn't it be 5 to the 1/2 power, or no?
Yeah, 5 to the 1/2. That's why I wrote here.
Okay, because I just see why. Okay, cool. Oh, I didn't even see that. It looked like a question mark and some dots. So then, can you just skip over C and do F?
So F is the same idea, right?
Right.
So say it's equal to y. Okay, so now we rewrite it. So what is the base? The base is this number here, right?
Yeah, 3.
So 3. What is the exponent?
Y.
The exponent is y.
Y.
And what is it equal to?
1/9.
The thing that's inside the log, right? To 1/9. So the thing on the left tells you that the base is 3.
So would
So,
it be 1/9 to the half?
well, why did we have the 1/2 before? The 1/2 from before was
Because it
Because
was a square root. Yeah.
right. So when there's a square root, then it's 1/2. But this doesn't have a square root.
Yeah. I'm just speaking alien language. Wait, so does it just stay there or no?
Well, okay. So now we want to do the same thing, right? So what did we do here? We made it so that it's 5 to some power, right? So I have to turn the 1/9 into 3 to some power. Right, so and I need to figure out what the power is. Okay, so you look at the number 1/9,
-2.
right? So first of all, the 9, how do you write it as 3 to a power?
-2.
How do you write 9 3 to the 3 squared? What do you mean?
Well, 9 is 3 squared, right? But it's in the
Right.
denominator.
-2.
What
-2.
does that mean? That means it's negative. So the exponent here is -2.
Oh, that's okay. So it can make it positive. Wow. Okay.
So that's where the -2 comes from.
Okay. And that's the final product, right?
Mm-hmm.
Okay. After that, um, so for 10, say we take A for example, is it as straightforward as you combine the variables and then leave that expression be?
I'm not
So it'll be
following what you're saying.
so it'll be for A, it'd be the next step after the original expression, it'd be 2 ln x plus the next, combined. If you get me.
No, I'm not.
So
Say
what
it
I'm
again.
asking is, do we just combine the like terms
What do you
and
mean?
leave?
What do you mean combined like terms?
So for 10a, the expression itself, how far would it have to be evaluated?
So you want to write it as a single logarithm.
Yeah, and then multiply the.
Okay, cool. That's easy. Wait, what's your name, Miss? The other one that's talking? No. I was just gonna ask if it's easy. Could you go over 11 C?
So 11C is almost like what we did
with 9.
in problem 8,
Oh, okay.
right? So here, it's on the left, you have 2 to the x plus 3, and then on the right, you have 1/8, right? But because we're working with exponentials, we want the base to match up, right? So I need to write this as 2 to some power.
Uh,
So how do I write 1/8 as 2 to some power?
oh no, why am I blanking?
Two raised to power minus 3.
Right, so 1/8 would be 2 to the minus 3 power.
Yes.
How did she get that?
Right, so once the bases are matched up, right, so the bases are the same, that means that the things in the exponent have to be the same. Right, so then it just becomes x plus 3 is equal to negative 3. And then you can just solve for x, right? So x is equal to minus 6. Did you follow that? The audio is coming in and out, so I'm not.
Yeah, oh yeah, it's definitely fumbling. Um, I okay. So first of all, I don't know how she arrived to negative 3. Is it because it's x plus 3, and that's what she took to the power? She
No, so
eradicated the variable.
what are we trying to do? We're trying to figure out powers for different bases, right?
Yes, right.
So how did we do that the other day? Trying to figure out the powers.
Oh, yeah. I need a lifeline.
So there was the table, right?
Oh, yes, matching as the multiplication table. Yes.
So what are we looking for? Base 2, right?
Paste. Yep.
Where are we? It's the base is 2.
Mm-hmm.
Right? And we want to figure out the power for which number? The number is 1/8, right?
Right. And then just match it up.
So on the table, when you have 1/8 in the powers, and when the base is 2, what is the exponent? The exponent is negative 3.
Negative 3. Okay. And then x plus 3 equals negative 3. Oh, okay. It's hard to fathom the simplicity in all this. Kind of like making it complicated for no reason in my head.
Okay, are there any other questions? There's a few other people here, but I don't think anyone is paying attention.
I mean, if I'm not being annoying as much as I've already been, Professor, if you can, for the grand finale, if you don't mind, Give me a second. I'll just tell you which ones. I put a check next to them. So if you can go over 11G, 11G 10C. Did you already go over 2 and 3, Professor? Or,
No,
okay. And then just
we went over 2 already. That was
okay. Yeah, yeah. And then if you could do one of the examples from 3.
okay. So for 11G,
G. Uh-huh.
So we're dealing with logs now, but it's kind of the same idea with the exponentials, right? So when and for the exponentials, what is the basic idea? When the bases are the same, once the bases are the same, then you just set the other part equal to each other, and then it becomes a regular equation, right?
And
So
just, uh-huh.
so for G, we want to follow the same idea except for with logs, right? So on the right side, I have a single log. It's a single natural log. So if I can make the left-hand side into a single log, right? Because there's 2 different logs, right? So this log and then this log.
Right.
So if I can turn that into a single log, then you just have to set the 2 things equal to each other, right?
Okay.
So I need to combine this.
To that, to the right half of the equal. Cool.
So you have to combine to a single log. Right, so what's the rule for combining logs? So if you have a sum,
Multiply.
then it turns into multiplication, right? So
Subtraction, and then subtraction is division.
yeah, subtraction turns to division, right? So now it's a single log, and what do I multiply? The 2 things that are inside, right? So
X plus 1 and 5.
so it becomes 5 times x plus 1,
5x plus 5.
right? So then this you can distribute, so it's 5x plus 5. Okay, so now the logs are the same, right? So I can ignore them, and then it becomes 5x plus 5 equals 3x plus 13.
Oh my god. X plus 1.
So it's kind of the basic idea, but you have to apply a different rule or like a different way of doing it, right? So I mean, here, once the bases are the same, they kind of cancel out, right? So once the logs are the same, they cancel out. But the way you get it into a single log, you have to apply the rule that if you have when you're adding different logs, it turns into multiplication.
Okay.
Okay, so then now this is just a regular equation, right? So 2x equals 8, x equals 4.
Yeah. Well, oh, okay. So you don't just leave it at combining to a single. You finish the expression. Okay.
So what was the other one? 10
It was 10C.
10C.
Yes, sir.
Okay, so it's kind of the same idea, right? So we want to combine to a single log, but you have to pay attention to what the operations are, right? So So
This is
addition turns into multiplication,
hmm
right? So here we have subtraction. Subtraction turns into division,
division.
right? And then we have another operation. There's also multiplication, right? So this 2 is multiplying the log here. This 3 is multiplying the log here. And then this 3 is multiplying the log here.
I could just get over with, right? Like I shouldn't cram at this point. But he's like
So
right behind
we
me.
want to take those things into account,
I was waiting.
right? So I mean, you can apply the operations one by one, but at least in my opinion, it's better to do it all at once, right? So so how do we do it all at once, right? So we write it as a single log, right? And then everything is combined inside. So how do you combine it? So
X into x minus 2 divided by x plus 2.
we-
Tell me,
no,
you can
we're
like
looking at
demand
C,
find on
not
the
B.
Google Doc if anything.
We're looking at C.
Oh,
Or
okay.
like try
So
put too much pressure on course here. I mean,
X into y divided by z.
right, so there's subtraction here, right? So there's going to be some division involved, and the rule you want to take is that terms that are positive go on top, and terms that are subtracted go on the bottom.
Mhm.
So this ln of x term is positive, so the x should go in the numerator. These two terms are negative,
Mhm.
so the y and z, they should go on the bottom.
Right.
Right, so that deals with the subtraction, and then now we have to deal with the multiplication. Right, so there's 2 times the log the log for x, and then 3 times the log for y, and then 3 times the log for z. Well, multiplication turns into exponents, right? So this x has a multiple of 2 in front, so I get a second power here. Let me change the color so it's easier to see. Green, right? So this 2, this 3, and this 3. Right, so this 2 goes with the x, so this becomes x squared. This 3 goes with the y, so it becomes y cubed. And then this 3 goes with the z, so it becomes z cubed.
Is that it?
Yeah, so that's it.
That's crazy.
So basically, you just want to read off the terms, like what the operations are.
And apply them to the proper variable. I think I'm good with that, Professor. Anything else, I'll ask you tomorrow, but that's all I had for now.
You also had a question on
Yeah,
3.
can you, if you don't, can you just go over 3C? That's
So
it.
3.
3C, that's the last one. Yes, please.
Right, so this one we want to use synthetic division.
Okay. I need to go over this one.
Right, so you want to first look at this number here, right? So which is a. A is always the opposite sign, right? So if this is x minus 3, a is going to be positive 3.
Okay.
So when we set up the synthetic division, a goes in the little box here, right? So that's 3. And then at the top, we write out the coefficients. Okay, so what are the coefficients? The first one would be 1, right?
Mm-hmm.
The next one would be
4.
negative
17.
4.
Negative 4. Negative 17 is positive
Negative
6.
17, and then positive 6. Okay, so you write out the coefficients one by one. And so now what is the procedure? So the first number we just bring down. Okay, so the 1 comes down. Then just fill in the numbers one by one. Right, so I have to calculate the number that goes here. So how do I calculate the number that goes here? You have to multiply, right? So this number times this number. So 1 times 3 is 3.
And then the
And you
and
add
then it'd
going
be
down.
negative 1.
4 plus 3 is negative 1.
And
And then
then
you repeat the
negative
procedure.
3.
Right, so negative
Negative
1 plus 3
20.
is negative 3, and then you add going down. So this is negative 20.
So then negative
And then,
60.
right, so
And then
then you multiply
56. Negative
with
50,
negative 60,
54.
and then this is negative 54.
That's it.
And then now we write out the answer. Right, so the quotient comes from this thing. So how do you write it out? So the degree should be 1 less than the thing you started out with. Right, so this was the original thing was x cubed. Right, so you want to
Yeah.
start the answer with x squared. Okay, so this is x cubed, so the answer should start out with x squared. So it's 1 times x squared, and then just go down, right? So then this would be the x term, and then this would be the constant term. And then the number that goes here is the remainder.
And that's the final.
Yeah, so that's how you would write out the answer.
So do we have to write minus 54 divided by x minus 3 at the end?
Just leave it as remainder negative 54.
Okay.
Yes, sometimes you would write it as a fraction, but here you don't have to worry about that.
Okay.
Whew.
The only thing you want to be careful about is if the thing that you are trying to divide is missing any terms. Right, so C is not missing any terms, right? So because it goes x cubed, then x squared, then x, and then the constant term. Right, so it has all the terms for C. But B is missing a term, right? Because it goes x cubed, and then goes straight down to x. So B is missing the x squared term. And so when it's missing an when it's missing some term, just put a 0 for the coefficient.
Wait, could you repeat that? The last part.
So you want to list out when you set it up, right?
Right.
You have to write out the coefficients one by one at the top row.
Okay, you're talking about you're talking about the division itself, right?
Yeah, the synthetic division.
Okay, cool.
When you start it up.
Yeah.
Okay, so when you start it up, all the coefficients go on the top row, right?
Mm-hmm. And then the well, I guess the number in the numerator is the one that you the quotient, the one that you divide with.
So when you set up the coefficients, you have to be careful if there's missing terms. So if you look at B, right? So the first term is x cubed, and then the term after that is an x term. So that means that B is missing an x squared. And so when it's missing a term, you put a 0 there.
Wait, for so then that for 6 you put a 0 there.
For 6. What are you talking about 6?
What did you where did you mean to put a 0 there?
Okay, so let's look at B, right?
Okay.
So if you do the synthetic division for B, so what number goes in the box?
That would be 2, positive 2.
-2.
Negative 2. Sorry, the
So
opposite.
it's
Yes.
always the opposite. Right?
Yeah.
And then what do you do after that?
Then you list out the coefficients, which would be 5, 6, and 8.
Right. So but it's not 5, 6, and 8
Whoa, why not?
because it's missing the x squared term.
5068.
A 5. Oh, yeah. So we must account for the chronological. Okay.
Right. So because there's no x squared, and so you have to put 0 in for that thing because it's missing a term. So when it's missing terms, it doesn't mean that it's not there. It's still there, but just the coefficient is 0.
That's really a crazy concept, because if we were to act like if we were to just move on as if the 0 wasn't there, then that would just it would mess up the whole problem, right? We wouldn't get the appropriate.
Yeah. Because then the procedure will break down.
Right. Wait, why did you write x squared on top?
So this was, I'm just showing you where the numbers are coming from.
Yeah.
So the 5 was for the x cubed. The 6 was for the x.
Okay.
And the 0 is for the x squared. And then the 8 is by itself. But when you do it, you don't need the x's at the top. I'm just showing you where the numbers are coming from.
Okay, that's perfect. Got it. Thank you, Professor. Yep. I'm gonna pray that it turns out to be as simple as you actually explain it. Because when we work it out, it's when I look at the problem, it's like, long story short, looking at climbing Everest or something, and then you solve it, and then you solve it.
Just practice the problems, right?
Yeah.
So it seems difficult because I mean, because you don't have the practice built in. Right? So when you work on the problems a few times, it becomes easier and easier.
Yeah, I mean, when we just did it right now, it went from seemingly climbing Everest to just climbing up like 2 steps of stairs or something. But yeah. We'll practice. Did you decide the exam date?
Yeah, it's gonna be Saturday and Sunday.
Oh, okay. 2 days you're gonna give us. Cool.
Yeah, you do it within those 2 days. Right?
Yeah.
So there's a time limit of 3 hours.
But we have a time span of.
Yeah, so like if you decide to do it on Saturday, right? So you have 3 hours on Saturday to do it, and then that's it. You won't be able to do it on Sunday, right? If you do it on Sunday, you won't be able to do it on Saturday, right?
Yeah, gotcha. Understood. And just the procedure would be go on Open Math, sign in, and the link should be there, right, to start up the exam.
Yeah, so I mean, if you go into the My Open Math now, you won't see it. It'll show up on Saturday though.
Gotcha. Okay. Gotcha. Thank you so much, Professor. But I will be most probably getting back to you with questions next day or two, just to reaffirm everything.
Okay, are there any other questions?
Nope.
There's other people here, but I think they
They-
just log in and then tune out.
Yeah, they just log in and probably they're on their episode of Netflix or their YouTube channel.
Professor, I have a question.
Yeah,
Okay, so how many chances we would have for the questions?
each problem has four submissions,
Okay.
but so I mean, if you enter in the wrong answer, right, and then so you have 3 more tries to enter in the answer. But it's slightly different than the regular homework problems, right?
Yes.
So, like for the regular homework problems, I mean, if you get it wrong a few times and you run out of tries, you can reload the problem and get a different problem, right?
Yes.
But that's not the case for the test. So once you use all 4 tries up and then the problem is incorrect, you won't be able to work on that problem anymore. So you won't be able to reload the problem.
And we would get to know that after solving that the problems are right or wrong at the same
Yeah,
time.
so yeah, once you enter in your answer, it'll tell you whether it's correct or incorrect and which
Right.
parts are correct or incorrect
Okay.
right away.
Right.
It just won't show you the answer at the end.
Right.
Professor, but what if we do it like twice? Like if we try twice, can we reload it? Reload the question after, or is it only after 4 tries?
No, so there will be no reloading the question, right? So you'll be presented with the problem, and you have 4 tries to submit your answer, and then once those 4 tries, if you use up all 4 tries, then that's it. You won't be able to reload the problem.
Okay.
So that's where the difference is with the versus a regular homework problem set. So if you like, say you do 3 submissions and you get to your last one, make sure you're very sure about your answer before submitting.
All right, can't wait for the easiest 12 questions in mathematics ever this Saturday. I'm just kidding.
Okay, so is there anything else you guys want to go over?
I'm gonna be. Oh, I'm sorry. Oh, she can go ahead.
So I think I went over this last time, but right. So each of these problems cover the various different topics, right? So problem 1 was from section 5.1. Problem 2 was this was section 5.2. Problem 3, that's division, so that's on section 5.4. Problem 4, I see you don't have to do part A. but I think it's technically from 5.3, I think. But I think the worksheet for the worksheet for 5.2 and 5.3 were together. Right, so where was 5 rational function? That's 5.6. 6 was,
Wait, 5 was 5.6?
yeah, 5 was 5.6. 6 is 6.1. 7 is also 6.1. 8 was 6.3. 9 is properties, right? So 6.5. This is also 6.5.
10 is 6.5.
11 was 6.6. 12 is 5.6.
And 8 was 6.3, right?
8 was, yeah, 8 was 6.3.
Thank you. I'm good for today.
Right, so and most of these problems are similar to the examples from those sections, right? So just go back to the worksheets for those sections and look up the relevant formulas. Right? So like what is the formula to calculate the vertex, and so on and so forth. So that was 5.1. This was 5.2. 5.2. Where's 5.2? Which one's 5.2? This one. So that's where, what is this? Page 3. Or that's also end behavior, right? So that was page 2. So that's page 3 and page 2. Okay, so this was 5.2, but specifically pages 2 and 3. And 5.4. And look up pages, I think page 1 and 2. Where was this example from? This was at the bottom of that page, right? Bottom of page 4. Rational, these were the rules. So 5.6, which page is the rules on? 1, 2, 3, 4, on this page 5. Six 6.1, I think this was pages 1 and 2. 6.1, I think this was page 3. And the others, there's scores sort of scattered throughout the pages because there's multiple problems. But in any case, so you should look up those specific things for each of the worksheets, and you should be able to find examples for each of these problems. Okay, so are there any Any questions?
For me, it's just gonna be if I have any questions, I'll just reach out to you through my open math or let you know here. I'll
Okay.
accumulate whatever questions. Yeah.
Okay. Yeah. So, well, I'm sort of asking if anyone else, but I think they've already found out. Anyway,
Thanks, Professor. Bye-bye.
so
Thank
yeah,
you so much, Professor.
if there's nothing else to discuss, so I'm gonna close the meeting.
Wait.
So I'll post this thing
Yeah.
with the annotations, so you can look over this again. Okay, so
Yeah, thank you, Professor.
I'll say bye to everyone. Just contact me over the next couple of days.
Will do. Thank you,
If
thank
you
you,
have
thank you so much.
any more questions on either those problems or how the test is set up. Okay.
Thank you, Professor. Yeah, I'm definitely gonna reach out to you. So you have a beautiful night.
Good night.
Yeah, thank you.
Thank you, Professor.